Good morning, students. So in last class we are discussing about metallurgy. So in metallurgy, so last class we had stopped at leaching process. So in the leaching process we have discussed about one example. So one more example is important is there. So what is the leaching process? Say if you take a metal mixer with impurity, so one will be dissolved. One will be dissolved in a suitable chemical and another one is undissolved in a suitable chemical. Say that type of a combination we are using leaching process. So here the example previously we seen the bauxite leaching compound is NaOH chemical substance we see. Next another one gold and silver. So gold and silver with impurities. So now this combination, so we are treated with NaCN, otherwise KCN. So it is a chemical compound in the leaching compound in the extraction of gold and silver. See, the gold and silver is what? D block ligands. Next, cyanide is what? Strong field ligand. See, D block element ligand is there. You must remember what? They are going to form a complex compound. So that means the NaCN and KCN react with this impurities are unreacted. So that means you are getting AgCN taken twice -1. Otherwise gold cyanide. So complex next impurities. See here, this is observed dissolved condition. These are dissolved in the form of liquid. So the impurities are undissolved, these are solid. So one is a liquid, another one is a solid. So by using filtration, so filtration we are removing the solid. So solid impurities we removed, remaining solution is there. So that liquid. So this liquid contains gold cyanide complex is there. Next silver cyanide complex is there. So now this is treated with zinc. So zinc reduction potential is more powerful than gold and silver. If you treat with zinc powder, zinc is going inside the complex and occupying the metal. Inside the metals are coming outside. So then what happens? Zinc will become as a zinc complex. So next gold and silver, they are separated out. These are coming out as a solid. This is a dissolved in the liquid. So then what happens? Again you use filtration. These are eliminated. You are getting pure silver and gold. Not pure, that is impure only. That is anyhow crude metal. This is called as crude metal. Okay, this is the last example of leaching. See, in the gold and silver leaching process, which reagent we are using? So NaCN and KCN. So that is important. So in metallurgy, we have completed first process. So now we are going to second process. So what is the second process? So already we are given. What is that? Preparation of crude metal. See, the second process in metallurgy. So preparation of crude metal. So purified ore. So purified ore is converted into crude metal. Here we have. So what is our shortcut we are given? Ore. So here, call row, smell. Next, Ellingham diagram. So this is a total second process. So here, purified ore first treated with the oxidation. So in oxidation we have calcination. So calcination process is there. Next, roasting process is there. Next, after that, so smelting process. So smelting is nothing but a reaction. See, what happens in the oxidation process? So here, oxidation process, all are, the ore is converted into oxides. So this is entrance. So what happens in oxidation process? The ore is, all ores are converted into oxides. Next, what happens in the reaction? So these oxides converted into crude metal. So crude, otherwise impure metal. So this is your entrance. Next, in smelting process, reduction purpose, what we are using, you can use carbon monoxide, otherwise metals. Which metals? First A group metal, second A group metal, so aluminium. So these are, otherwise hydrogen, otherwise water gas or syngas. So we are using the reduction purpose. Next, what Ellingham diagram is explains. This is the supporting of our thermodynamics. So spontaneity. So we are going to discuss in this. So here, first point we are going to discuss oxidation. So oxidation. So already we discussed in oxidation what happens, the ore is converted into oxides. Here two processes are there. So one is calcination. So what is the meaning of calcination? Heat the compound without air. Otherwise a little amount of oxygen you are heated. So that is called as calcination. So what happens in the calcination? So without heat, we are heating. Without air, we are heating means, suppose you take gypsum. So CaSO4, 2H2O. So we are heated this. First of all, who are easily eliminating that compounds are going outside. So CaSO4, so water vapor is going outside. Next, MgSO4, 6H2O. We are heated, you are getting MgSO4, water vapor is going outside. Otherwise, easily eliminated CaCO3, we are heated. So then what happens? Carbon dioxide is going. So CaO plus CO2. Otherwise, already ores we seen combination of calcium carbonate, magnesium carbonate, you are getting MgO, CaO. 2 moles of carbon dioxide. Next, suppose you take a copper hydroxide, we are heated, you are getting a copper oxide plus water vapor. So whatever the compounds are easily eliminated from the ores that are eliminated. Who are easily going? Water vapor, carbon dioxide, carbon monoxides, such compounds are easily eliminated. That is useful of calcination. Next, B. Roasting. So the roasting means what? The ore, the above compounds are heated in the presence of air. In the presence of air means nothing but oxygen. So what happens here? Suppose the ore impurities, sulfur, S8 is there. Suppose it is become as SO2 gas and going outside. So phosphorus is there. So that is P2O3 or P2O5. So that gases are going outside. Suppose arsenic is there. So arsenic oxides. So that is smaller. The non-metallic volatile impurities are there, means they are easily oxidized and they will go outside. Next, other than this, so mainly the sulfide ores. So here the main important is roasting process. The sulfide ores. So sulfide compounds are converted into oxides. So this is the very important. So you take Cu2s is heated with oxygen. So then what happens? So Cu2O, SO2 gas. You can balance that. So lead sulfide. So lead sulfide, oxygen. So sulfur is eliminated. So PbO plus SO2 gas. So like that. Suppose Zn gas with oxygen, you are getting ZnO plus SO2 gas. So some problem also it will be happened in some compounds. So in what way means the same. These two examples only you take. So PbS is treated with oxygen. So some amount it is going to PbO and some amount sulfur is reacted with oxygen. You are getting a PbSO4. So some other impurity is forming. So that possibilities. So next zinc sulfide. So zinc sulfide is treated with oxygen. So some amount is converted into zinc oxide. Some amount is converted into zinc sulfide. So for this type of reactions, the temperature is important. At which temperature it is forming, at which temperature it is forming. Based on that logic, you can easily separate in this. Next, one more important thing here. Suppose any acidic compounds are there. So acidic impurities are there, or basic impurities. So in oxidation, one more important point is, suppose that ore contains so acidic impurity, so SiO2. So that is impurity. See, this is what acidic impurity. Suppose the ore contains CaO, basic impurity is present. So this is treated with calcium oxide. So this is called as a basic flux. See, basic is there. We are adding with SiO2. This is acidic flux. So then what happens? So CaSiO3. So CaSiO3. So that waste slag, we call it as a slag that is eliminated outside. So based on the impurity, which compound we are going to add. So that is also very important in this. Next. So oxidation is over. In oxidation we have calcination is there, roasting. So both are completed. See, next reduction process. So reduction. So second process we call it as reduction. So in reduction what happens? Metal oxides. So metal oxides are become as crude metal. Crude metal, otherwise impure metal. So main concept is that. So here smelting process, it is also we call it as a smelting process. So in smelting process, what are the reducing agents? So already we discussed what are the reducing agents: carbon, carbon monoxide, hydrogen, carbon monoxide and hydrogen combination, first A group, second A group, next third group of aluminum. So high reduction potential. So these are. So in this we are discussing some more possibilities. So carbon reduction. Suppose we see the reduction with the carbon or carbon compounds. See, you are taking zinc oxide. Zinc oxide reacted with carbon. You are getting zinc, carbon monoxide is going outside. So mercury oxide, so treated with carbon monoxide. So you are getting mercury is separated, carbon dioxide is going outside. So anything, all oxides, Cu2O react with CO plus H2. Hydrogen gas you take. So 2 carbon is coming outside, H2O water vapor is going outside. So you can use anything. So that is carbon, carbon monoxide, hydrogen, otherwise water gas. So that chromium oxide, Cr2O3 treated with water gas. So then what happens? Chromium is separated, CO become as CO2 gas, H2 become as H2O water vapor, and so on it will go. Next, another reduction. So some compounds, self-reduction. So second, we can see self-reduction process. See in oxidation we see what you see either it is majority observed in the D block elements only. See you take mercury sulfide. So it is treated with oxygen. What happens in the previous oxidation process? So mercury oxide, SO2. So suppose you take 2 moles. So how many oxygens? 2 plus. So 3 by 2 oxygen you can take. See this HGS again react with HGO. HGO. So 2 moles. Then what happens? Mercury is coming outside, S combining with oxygen. So 3 moles of mercury plus SO2 gas is going outside. So this is a self-reduction process. Suppose you take copper sulfide, so treated with oxygen. So what you will get? Cu2O plus SO2 is again that Cu2O react with Cu2S. So this is a self-reduction. So you are getting 2 moles. 4, 5, 6. 6 copper is coming outside. SO2 gas is going outside. So self-reduction also one more. Next. So third. So that is aluminothermic process. So aluminothermic process is there. So that is treated with. So that is Fe2O3. So Fe2O3 reacted with aluminium. So this is a 3:1 ratio. This is called as a thermit. See, suppose these are treated with, we are heated with magnesium. So magnesium wire, in the presence of magnesium wire, for initiation of the reaction, so strong, magnesium plus barium peroxide. You take, this is the igniting mixture, is connected with magnesium. First it is burning. So after that, with this temperature, both are reacted. So then what happens? This is a high reduction potential. So you are getting Al2O3 plus iron is coming outside plus energy. So the aluminium remove the oxygen, so iron will come. At this highest temperature, this iron is available as a liquid form also. The liquid metal is available at room temperature. This is the highlight of aluminothermic process. See, not only this one, you take Cr2O3 treated with aluminium. So you are getting Al2O3 plus chromium energy. So you are getting. So we see that aluminothermic process also. Next, one more reduction is there. That is electrolytic reduction. So four important points in this. So electrolytic reduction. So we are applying electrochemistry. So which metals are powerful? So you take first A group, second A group, and aluminium. So these are strong reducing agents. Suppose you treat it with the carbon. So carbon monoxide or water gas. So these are not useful reducing agents to extract these metals. So these metals are compulsory. We are using what? Electrolytic process only. Suppose you are using sodium. Suppose you want to prepare sodium. So what are the famous electrolytic process? See, Kastner's process. Next, Downs process. So in Downs process, what is electrolytic solution? NaCl, brine solution. So Kastner process, NaOH. So in what way we are taken NaCl solution? So NaCl, molten NaCl we are taken. One is connected with positive, another one is connected with negative. So Na plus is deposited on cathode. Next, Cl minus is coming to anode. So the chlorine gas is going outside. So this electrolysis process only we can prepare not only sodium, so magnesium also, aluminium also. So aluminium we are using bauxite. After completion of this chapter, we are going to discuss about aluminium and iron also. So who are prepared? Which metals are prepared in the electrolytic process? Direct answers, questions. So means what? First year group, second year group, aluminium. You remember this thing.